Greetings, Integrated 3 students! Welcome to the second video in this series entitled Exponents and Roots number 2. Now you'll see that Exponents and Roots number 1, along with the posted YouTube video, is right on your page. Hopefully you've gone there, you've checked it out, you've done the assignment, and now you are ready for the second one. Exponents and Roots number 2. Now, I'm not going to spend nearly as much time as I did last time telling you about how things are set up and logging in, all that stuff. I'm just going to assume that you've watched the last video and could figure it out. And so we're going to dive right into it. Make this a little faster this time. Right off the bat, you can see I've got my Desmos Calculator set up on the right with a lot of the same calculations that we had last time we did this. Now I am going to leave that up, but I can clear this a little bit. Although I can do what I did last time and remind you that you can hit functions, this in above the square root sign, and then you could type a 3 in that, and that'll be the cubed root of whatever we need. Alright, so we learned last time about our EMO acronym that we will use, SADME, for additional problems, but we also learned that these first ones are just simply take the square root of both sides and figure out what x equals, both positively and negatively, because we're going to have two solutions. So I can come over to my Desmos Calculator, which again hopefully you have in a separate window, and you type in square root of 4. And it, of course, tells you 2, because 2 times 2 is 4. So then, if I just put in 2, I'm going to get it wrong. I'm going to get partially credit for it. So I do 2 comma negative 2 to make sure I get both answers. And then for number 2, I've got my first 3, x3. And so to get rid of the 3, that's why I have open this cubed root over here, which again, you can get there by hitting the functions key and then hitting the one with the little in over a x power. Again, this little in over the square root sign there, and then plug in 3 for n. Once you do that, you could plug in whatever you have on the right side of number 2, mine's 343, and you'll see it tells me 7. And once again, I don't also have negative 7 as an answer, because negative 7 to the third power, as we discussed last video, is negative 343, because it has an odd exponent. You only need 2 answers when you have an even exponent, and for this assignment, that's only true when you have a 2 by the x. Okay, that's 1 and 2. Then 3 is another cubed root problem. So I go over to Desmos and I type in negative 216, and it tells me it's negative 6. Okay. Moving right along. Number 4 is our first true algebra problem. That's more than one step. It's a 2-step problem technically. A Texas 2-step, ode to my birth state. And once again, we're going to want to do the opposite of what's happening on both sides using SADME. So subtract and add first, then divide and multiply, and finally exponents. Well, subtracting and adding, I am subtracting on the left side specifically by 11. So I'm going to do the opposite and add 11 to both sides. To get x squared is 49. Now I can take the square root of that. What number times itself is 49? Maybe you remember your mental math from earlier in life. 7, negative 7. So I can go down there. Again, if you can't do that in your head, no worries. That's what you've got this Desmos Calculator open to on a separate window. And as always, if I'm going too fast, pause the video, rewind it. If I'm going too slow, you're already on number 6 or something, skip ahead to number 6. I'm getting some feedback already from students, and it's just so wonderful to have these in video form because you really can go at your own pace. Something that we cannot do if we were in real life in our building. So little things to be appreciative of right now, given this era, being able to watch a video at your own pace. Okay, you might be scarred from my description of what this was last time. A number next to a letter without a symbol in between. I said the same thing I do in class all the time. These are like bunnies they're stuck together in a cage, and when bunnies are stuck together in a cage, they multiply. So we need to do the opposite and divide. Half of 200 is 100. And the square root of 100, what number times itself is 100? 10. And I put two answers because, once again, I have a 2 for my x squared. So 10, comma, negative 10. And because this is technically an extension assignment of the last one, you may have just flown through these first 5, as students often do. And now you're stuck on number 6. Why? Because even though it's the same type of problem, we have something new. What's new? We have decimals. We're going to have to write our answer as a decimal rounded to the nearest hundredth. That means we're going to have to remember how to round, and we're going to specifically have to remember how to round to the nearest hundredth. So, here we go. Little breakout session. I'm going to add a little chalkboard here. This is decimal rounding. All right. As always, I apologize for my hideous handwriting and remind you I'm writing on a screen with a not too quality stylus pen. So decimal rounding. If I have any decimal, I'm just going to write one out here. And I want to round it. I got to remember that this first 4 is the tenths place. This 5 is the hundredths. Then we have the thousandths, the 10,000ths, the 100,000ths, on and on and on. But for right now, especially so you don't have to see me write out horrifically any more of these words, I'm going to leave it at that. Because what we're going to focus on is this hundredths in our lesson today. And here's what that means. I can ignore every single decimal past the number on the other side of this little wall I've drawn here. It doesn't matter. Sometimes people get screwed up. They'll round like here and then think, oh, since I'm rounding here, that means I round here and then round here. No, ignore all of this. These numbers don't exist when it comes to rounding to the nearest hundredth. Instead, all I'm going to do is I'm going to focus on this 6, and I have to ask myself the following question. Self, do I leave this as 3.45, or does it become, so is it 3.45 or 3.46? Those are my only two options when I'm rounding to the nearest hundredth. I'm not 3.5, it's not 4, 3. Hundredth means at the end of this rounding, I have to have a digit that matches each of these places here for the tenths and hundredths. So then I ask myself the following rhyme. I say, self, is this number to the right of this wall 5 or above? Meaning 5, 6, 7, 8, or 9. If so, then I'm going to give this 5 a shove. And I'm going to bump it up to be the 6. And the rest of the rhyme is, if it's 4 or below, so that's 4, 3, 2, 1, or 0 to the right of my wall, then I leave it a low. Nah. So again, 5 or above, give it a shove. 4 or below, leave it a low. Nah. And hopefully that will always help you round. The key is just drawing your line in the correct place, right past where you're rounding. So since I'm doing the hundredths, it's right past that spot. And then just looking at the one digit past the wall and ignoring everything else. So in this case, because 6 is 5 or above, I'm going to give it a shove up to 3.46 in this hypothetical problem. But that wasn't my problem. That was just a number I made up. My problem now is I need to have the square root of 84. So I take the square root of 84, and I get this nasty decimal. And so I'm going to, in real time, I'm going to draw a line. You'll notice I am over here now, to the right of this 6. And then I'm going to focus on the first number after. That's a 5. And I say, okay, is that 5 or above? Well, yeah, it's a 5. So then I round that up and give it a shove to 9.17. 16 goes up to 17. You can see again, there's the 6 that's right there. So I make it 9.17, comma, negative 9.17. And yes, you do need both answers because it still has a 2. And there you go. All right. Then we get to practice decimals with cubed roots. So I type in the cubed root of negative 70. And I see, once again, focusing over here at this long decimal, that my options are going to be negative 4.12 or negative 4.13. Well, look at that number there. Is that 5 or above? Nope, it's a 1. So that's 4 or below. So I'm going to leave it alone. And it's just going to be negative 4.12. Because it's a cubed root, I don't need 2 answers, just like I've done all the rest of them. Negative 4.12. Yay! Then we've only got 4 problems left. Because there's a number 11 on this one. Did you notice that? Okay. Number 8. We have our rabbit situation again. So I'm going to divide by 4. That gives me x squared. If you're writing these out one at a time, again, you can just pause the video and then get an answer and maybe check your work at the end. Totally up to you. 68 divided by 4 is, let's see, 17. The square root of 17 is, let's go over to my Desmos Calculator. Let's make sure I did that correctly in my head because I am human. And I could make mistakes. Nope, but that's 17, so great. So then the square root of 17, 4.123. That's fun, 4.123. So once again, 4.12 or 4.13. This third digit is less than 5, so I'm going to leave it 4.12. But I do need to put comma, negative 4.12. And notice I didn't write out the whole wall on that one. I've done enough examples. Hopefully you're catching on. And you don't need those extra steps. But if you do, you can just go backwards. All right, number 9. This one is always a little bit tricky because it has a fraction. And a lot of people do not enjoy fractions. And I get that. It makes sense. Fractions are a little bit counterintuitive in life. We use them for lots of cooking recipes. We could use them for like pizza. I'm going to take half this pizza and eat it. But it's a lot less used in life than decimals. Decimals we use all the time with money. So if you're ever like, man, I'm good with a decimal but not a fraction, I don't know why, that's probably why. And that's okay. We value decimals in society a lot. And that's why a lot of times I just suggest that students turn fractions into decimals when they're comparing, because we're so much more used to comparing decimals than we are fractions. All right, I want to solve for x, and I need to get rid of this 1/2. Well, once again, even though it's a fraction, there's no plus or minus sign in between. So this is technically the rabbit situation again. It's multiplying. So then I need to divide by this decimal. This fraction. So you can either divide by a fraction, or you can remember a little middle school KCF, keep it, change it, flip it, which is that dividing by 1/2 is the same as I keep the first number, I change the division sign into a multiplication sign, and then I flip. The 1/2 becomes 2 over 1. And 17 times 2, or 17 times 2 over 1, is 34. Then I take the square root of 34. So that's a lot of information. Let me show you on the calculator. You can either say, I can already hear a lot of you guys out there. What? You're going too fast, huh? What? I can divide that by my fraction. And actually, because if I use that as a division key, it's a little confusing. I guess you have to do it that way. I can either do it like that, 17 divided by 1/2. Or I can do 17 times 2, and you could even put 2 over 1 if you wanted to. Either way, you're going to get 34. And then if I take the square root of 34, scroll up to that. You get 5.83. Is it 5 or above next to the 3? 0. Nope, that's the lowest possible. So I leave it as 5.83, comma, negative 5.83. All right. And finally, on number 10, we have say finally because there is number 11, but these regular ones, then we'll tackle number 11 separately. We finally have the 3-step beast, where we need all the elements of sad me. We're going to need, just like we did in the 9 and 10 of the first assignment, subtraction and adding, division and multiplying, and finally exponents. And I really want more room to do this problem. Maybe I'm going to write it up. I'm going to write it like up here and then just go vertically from there. All right. X squared minus 28 is 40. Otherwise known as 28 less than x squared is 40. There's my line to keep with both sides. If you missed my analogy about my brothers and goldfish last time, go back and watch that. Basically, it boils down to make sure you always do the same thing on both sides of the equation. We start with our subtraction and addition. I am subtracting, so the opposite is I'm going to add 28 by both sides. So x squared is 68. Then, oh my gosh, I thought we had a 3-stepper, but we actually don't. Notice, we don't have any division and multiplication. We don't either have a fraction or the rabbit situation. So we actually can go directly from step 1 to 3 and just take the square root. Oh, it's a little bit of a bummer. I didn't need all this extra room that I made for myself. That's fine. I'll just take the square root of 68 and be good to go. All right. So let's clear this out because I'm starting to get a lot of this. And again, I say, what is the square root of 68? 8.24. Does it round up? Let's look at that third number. Is that third number 5 or above? Yes, it's a 6. So I give it a shove. 8.25, comma, negative 8.25. And again, if you need more explicit rounding directions, refer back to my first few problems, like numbers 6 and 7 when we had decimals, and I went really step by step there if you need more practice. All right, finally, this is kind of for fun problem. Number 11, an extension problem. If you're out there, especially if you're watching this and you're not in my class, why don't you try this one on your own? Pause the video and see if you could just straight up solve this one. All right, well, if you've unpaused now, let's go over it. It says enter and answer answers that correctly fill the blank. Solve for x, use 3.14 for pi, and round your answer to the nearest hundredth, if necessary. Include units in your answer. First time we're going to be doing that, and that's why it's both bolded and underlined. The area of the circle is 200.96 millimeters squared. Solve for x. Where to start with this one? Well, in this word problem, everyone's favorite word problems, I know, we need to figure out what the area of a circle is. Now, we have the internet, which is absolutely great because if you ever find yourself forgetting what area of a circle is, you can just Google it. Or you can ask Siri. Notice I didn't type in circle correctly, but even if you don't type in circle correctly, it's smart, it's Google. A equals pi r squared, which means we take pi and we multiply it times the radius squared. Okay. Cool. So we know that pi, notice it tells us we're going to use 3.14 for pi, so I'm going to write out 3.14. Of course, my stylus is deciding to be a little icky. Times the radius squared. We don't have the radius, but we do have the area of 200.96. So now, notice I've got my rabbit situation here between the pi and the r squared. It's multiplying, so I can divide by pi. And that leaves r squared. So then whatever I get there, I could just take the square root of. And that will give me my radius. Okay. Well, let's try that. This is an advantage for you because you can have the calculator open at the same time, whereas I have to close out on my writing. But you can just pause your video while I had all that helpful writing over there. And you can even do this in one step. I'll show it to you in 2 steps first. 200.96 divided by pi. 64, which then we could do the square root of 64. And you get 8, but you notice you can also do the square root of 200.96 over 3.14. So this whole thing is one step like you would in a graphing calculator. And it's so smart. it still tells you 8. Now, notice a couple things. One, this is our radius, and this is asking for the entire diameter. So if you typed in 8 because you got really excited and you already hit check, you're going to be kind of distraught as it tells you you're wrong. Instead, we need to double our radius. So whatever you got, multiply it times 2. 16, but if you got super excited and you hit check, sorry, you've also missed it for a second reason. I could just hear people being frustrated in class right now if we were there. Why? Because of that thing I said at the beginning about was underlined and bolded. We need to use units in our answer. Well, millimeters squared. We've taken the square root so we can get rid of the squared. We're just in one dimension now. Feels a little matrixy saying that. 16 millimeters. Now you can either have a space there or not. It's totally up to you. And you'll notice because this is an extension problem, it does give me my nice outstanding green message, but it's also filled in gray, which tells me that it's not going to be factored in the same way as the other ones in my grade, which is also when I hit finish attempt, why it has a 0 there. Even though it tells me I'm correct, it's not going to be factored in like the others because it's extension practice. And then I could submit, and voila, 100. It took me about 20 minutes. You can see I filmed this on Monday, April 13th. I am going to, straight up, trying to film a lot of these before I post them, even weeks before, because, a reminder, everybody, I'm going to be a father, and I don't know when that's going to be. The due date's in about 6 weeks, but the thing about kids is they could come way early if they want to, or late. I cannot take that chance since I'm going to be simultaneously being a dad for the first time and trying to be your teacher from afar for these 4 weeks or so at the end of the year. So to make my life easier in the future, I'm going to record a lot of these now. That's why this date is going to look so different if you're watching this next week or in a soon video in a month maybe from when I end up filming it. So that's a little explanation there. I cannot wait for that birth. I cannot wait to be a dad and to send you pictures of our adorable, I'm sure, daughter that hopefully looks much more like my wife than it looks like myself. All right, with that, I think I'll end the video just by saying, once again, I hope that you're all safe out there, that you're healthy, that you're well, and that these videos are helping you out. It is your teacher, Dylan. This has been Class Away from Class. Thank you for watching. Much love and best wishes out there.